Are you struggling with the CPA exam because your course failed to fit your learning style? I'm Darius Clark of I-75 CPA Review, where the right teacher makes all the difference. All right, what do we have to know about relational databases? A relational database is a collection of data that is organized in a way that allows for efficient storage, retrieval of data, and manipulation. Manipulation refers to being able to update and also maybe even delete data from the database. So the exam will require you to know the major components of a relational database. In a relational database, tables are used to store data records. A table is essentially a collection of rows and columns, where each row represents a single record, and each column represents a field or attribute of the record. Each table is given a name, and this name is used to reference the table when performing database operations like select, insert, or delete. Tables are usually named in a way that makes their purpose immediately apparent. For example, a table that stores information about vendors might be called vendors, while a table that stores customer information will be called customers. Each row in a table represents a single record. For example, in a customers table, each row might represent a single customer, with columns for the customer's ID, the customer's name, the customer's email, credit rating. Since each row in a table is intended to store a single record, this makes it easy to query, update, or delete individual records without affecting other records. All records in a table have the same structure defined by the table's schema. This makes it easier to write SQL queries and maintain the database. Records can be inserted, updated, or deleted as needed, and the table's structure remains consistent even if records are changed or removed. All right, which of the following is correct regarding a relational database? A, tables are a collection of rows and columns used to store data records. Yes. B, each row in a table represents a single record. Yes. Letter C, both are correct. Tables in a relational database are a collection of rows and columns used to store data records, and each row in a table represents a single record. All right, we talked about the rows. What about the columns and fields? Well, a field refers to a single data element for a specific column in a specific row within a table. So here's a table named customers with columns like ID, name, and email. Notice how ID is a separate column than name. Name is a separate column than email in the table known as customers. So the field under the name column for a row where the ID is 1 is Joe Riley. We'd say that Joe Riley is a field located in the name column for the row where the ID is 1, because Joe Riley is customer ID number 1. Okay, then what's a schema? A database schema is the formal structure that describes how data is organized in a database. Schema serves as a blueprint that outlines how the database is constructed, including the tables, columns, data types, relationships, constraints, and other elements that make up a database. Schema is used to define both the logical and physical aspects of the structure, helping both database designers and users understand how data will be stored, accessed, managed. What about a primary key? The primary key of a table is a column or set of columns whose values are unique across the table. This ensures that each record can be uniquely identified. Primary keys are often automatically indexed, which significantly speeds up data retrieval operations, and they cannot have any null values. Fields that are part of the primary key cannot contain null values, as each entry must be unique. Each entry must be identifiable if it's a primary key. A null value is the absence of a value, or it could be an unknown value. Let's go back to our customer table. The ID column could serve as the primary key because each customer ID is unique. Each customer ID is unique for each customer record, which makes customer ID a good candidate for primary key because two customers, while they might have the same name, they should not have the same ID number. So if the ID column contains unique non-null values, then it will be appropriate to designate it as the primary key of the customer's table, and it normally would be. However, the mere presence of an ID column with unique values is not sufficient enough to determine if it's a primary key. That's a matter of how the database was designed, and we know that's up to the database schema, which defines the structure and constraints of the database, and the schema would indicate whether the ID column is indeed set as the primary key. So when you think primary key, think unique. All right, a foreign key is used to establish a relationship between two tables. A foreign key is a field in one table that is used to refer to the primary key in another table. And this linking ensures that the records in the two tables can be matched, maintaining data integrity and allowing for more complex queries. For example, the customers table we said has a list of all your customers and each one has a unique ID. Joe Riley is one of those customers. His unique ID is 1. So that's the customers table. Now we have an orders table that keeps track of all the orders made by these customers. In this orders table, you have a column named customer ID. The customer ID in the orders table serves as a foreign key that points to the ID in the customers table. So if Joe Riley, who has an ID of 1 in the customers table, makes an order, you would put 1 in the customer ID column for that order in the orders table. This way, the foreign key, the customer ID in the orders table, helps you know that this specific order was made by Joe Riley from the customers table. It's like a way to connect the two tables and keep everything organized. All right, what's the primary purpose of a table in a relational database? Is it A, serves as a blueprint that outlines how the database is constructed? No, that's the schema. B, is it to store data records? Is that the primary purpose of a table? To store records? Yes. C, to serve as a unique identifier? No, that'd be a primary key. So B is correct. The main purpose of a table in a relational database is to store data records. Each table represents a specific entity, such as a customer table, an order table. Each table holds the actual data in rows and columns, making it easy to organize, store, retrieve, and manipulate data. A is wrong. While a blueprint or schema is important for defining the structure of a database, it's not the primary purpose of a table. The table itself serves to store data, not to outline the entire database structure. And C is wrong. Unique identifiers, often called primary keys, are a feature of tables, but they're not the primary purpose of a table. The primary key serves to uniquely identify each record within a table, not to be the main reason the table exists. All right, which of the following is used to uniquely identify a record within a table? Is that a foreign key? No. A primary key? Yes. B is correct. The primary key is used to uniquely identify each record within a table. Each table can have only one primary key, and the values in this column must be unique and not null. When a table is defined, one of the columns is specified as the primary key, ensuring that no two records can have the same value in this column. So B is correct. A is wrong. A foreign key is used to establish a link between the data in two tables. A foreign key is a field or set of fields in one table that refers to the primary key in another table. The table with the foreign key is sometimes called the child table, and the table being referred to by the foreign key is called the parent table. While foreign keys can be unique in certain contexts, they are not generally used to uniquely identify records within their own table. And C is wrong. A schema is like a blueprint for the database that outlines the structure, relationships, and constraints, including tables and their attributes. Schema is not an individual element that could be used to uniquely identify a record, though, within a table. That's the role of the primary key. All right, what does a foreign key do? A, increases database size. No. B, defines the database schema. No. C, links tables together. Yes. D, provides encryption. No. C is correct. A foreign key is used to establish a relationship between two tables. Specifically, a foreign key is a field or set of fields in one table that is used to point or refer to the primary key in another table. This linking ensures that the records in the two tables can be correspondingly matched, maintaining data integrity, and allowing for more complex queries. You should know the term referential integrity. Consider we have two tables. We have orders and we have customers. The orders table may have a customer ID foreign key, we said, that refers to the customer ID primary key in the customers table. Well, referential integrity would prevent you from adding an order with a customer ID that doesn't exist in the customers table. Referential integrity is primarily concerned with maintaining data consistency across related database tables. It ensures that relationships between tables remain consistent by making sure that any field in a table that is declared as a foreign key contains only values that exist as primary key values in their linked table. So referential integrity ensures that the database remains accurate and reliable. Okay, so then what is normalization? The purpose of normalization is to eliminate data redundancy and improve data integrity by ensuring that each piece of information is stored in the most logical place. Normalization makes it easier to maintain and update the database. It also leads to more efficient use of storage. This involves decomposing tables into smaller, more manageable tables, where each table serves a single purpose or closely related purposes. Each attribute, each column in a table should be relevant to a unique key in that table. So normalization is concerned primarily with how to best structure the tables and relationships between them to eliminate anomalies and inconsistencies in the data. So the difference between normalization and referential integrity: normalization is about the structure and design of the database. How do you organize the data to minimize redundancy and improve integrity and efficiency? That's normalization. Referential integrity is about consistency and rules. Once you have this structure, how do you ensure that the relationships between tables are maintained correctly over time? So regarding databases, what is the primary aim of normalization? Is it A, to reduce data redundancy? Yes. B, to increase database size? No. C, to increase processing speed? No. Letter A is correct. The primary aim of normalization is to organize the database to reduce redundancy and improve data integrity. By ensuring that data is stored in such a way that it is consistent across the database, normalization minimizes the chances of data anomalies, which can occur when you insert, delete, or update data. B is wrong. Normalization generally aims to reduce data redundancy, which in many cases will reduce the size of the database rather than increase it. And C is wrong. Normalization does not focus on increasing processing speed. In fact, sometimes normalization can result in slightly slower query performance because the database may require additional table joins to gather the data. However, the benefit of improved data integrity with normalization generally outweighs this cost of a slower speed. All right, what is the main focus of referential integrity? Is it A, data consistency? Yes. B, data compression? No. C, data encryption? No. So letter A is correct. Referential integrity is primarily concerned with maintaining data consistency across related database tables. It ensures that relationships between tables remain consistent by making sure that any field in a table that is declared as a foreign key contains only values that exist as primary key values in their linked table. And this ensures that the database remains accurate and reliable over time. B is wrong. Referential integrity is not concerned with data compression. Compression is a method to reduce the size of data for storage or for transmission, but that's not focused on maintaining the consistency or integrity of relational data. And C is wrong. Data encryption is concerned with securing data, not with maintaining the consistency or integrity of data across related database tables. How about this? What do you call a blueprint that outlines the structure, relationships, and constraints of a database? Is that a SQL? And if you think you know, leave me the answer in the comments section. And remember to like and subscribe because it helps the channel out a lot. And if you need more help with any part of the CPA exam, go to i75cpareview.com and get yourself on the right road. Get yourself on I-75 today, because the right teacher makes all the difference.